Hello dear students, today I'm going to take up Unit 7, the P block elements of class 12. In class 11, you have learned the chemistry of the elements of group 13 and 14 of the P block of periodic table. In this Unit 7, you will learn the chemistry of the elements of subsequent groups, that is 15, 16, 17 and 18. Before we go into detail of Unit 7, let me refresh your knowledge of what you have learned in class 11. So, this is the modern periodic table given by Henry Moseley. He divided the periodic table into 4 blocks: S block, P block, D block, and F block. Now, what are P block elements? Elements belonging to group 13 to 18 are called P block elements. In other words, P block elements are those elements in which the last electrons enters the outermost p orbital. For example, an element fluorine, which has an atomic number of 9, has the electronic configuration 1s2, 2s2, 2p5. From this electronic configuration, we can see that an element fluorine has got 7 valence electrons in the second shell, in which the last 5 electrons enters the outermost 2p orbital. So, fluorine is a p block element. However, helium is the exception. Reason: helium is having electronic configuration of 1s2, that is a configuration of s block element, then it should be kept in s block. But it is not placed because of its properties only that match with inert gases, that is group 18 elements of the p block. The valence shell electronic configuration of the p block is NS2 and P126. Let us now try to understand how we can write the electronic configuration of group 15 of the p block of periodic table. Let me talk about the first one, that is nitrogen. Nitrogen is the one which has an atomic number of 7. So that's the reason we could write the electronic configuration as 1s2, 2s2, 2p3. And if we talk about the next element that's belonging to the group 15, it's phosphorus, which has an atomic number of 15. And we have the electronic configuration as 1s2, 2s2, 2p6, 3s2, 3p3. And suppose if we are talking about arsenic, which has an atomic number of 33, we can write the electronic configuration as 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p3. Let me elaborate the electronic configuration here. That is, if we talk about the valence shell of nitrogen, it is the second principal shell, but the electrons present in the inner shell, that is 1s, is basically 2. If we consider phosphorus, it is the third principal shell, which consists of 3 electrons in the 3p orbital and 2 electrons in the 3s orbital, making it to have 5 valence electrons, and the inner shell, that is 2s and 2p, has got 8 electrons. If we talk about arsenic, then the valence shell is 4s as well as 4p, so making it to be 5 electrons as a valence electrons, and inner shell 3s, 3p, 3d. This will totally make 18 electrons in it. So now we can write the general electronic configuration of group 15 as NS2 and P3. That is, the s orbital in these elements is completely filled, and p orbitals are half-filled, making their electronic configuration extra stable. Now let us look at the trends of some atomic properties of group 15 elements, such as atomic and ionic radii, ionization enthalpy, and electronegativity. So the first atomic property of group 15 elements is atomic and ionic radii. From this table, we can see that on moving down the group, that is from nitrogen to bismuth, the atomic radii, covalent radii, and ionic radii increases. This is due to the addition of new principal shell in each successive element. There is a considerable increase in a covalent radius from nitrogen to phosphorus. This is due to the effective shielding of the s and p electrons present in the penultimate shell of phosphorus. However, from arsenic to bismuth, there is only a small increase in covalent radius due to the poor shielding of the d electrons of the penultimate shell in arsenic and antimony, and the poor shielding effect of the f electrons of the antipenultimate shell in bismuth. As a consequence, the effective nuclear charge increases, which leads to a small increase in the covalent radius from arsenic to bismuth. The second atomic property of group 15 elements is ionization enthalpy. So what is ionization enthalpy? Ionization enthalpy is defined as the minimum amount of energy required to remove the most loosely bound electron from an isolated gaseous atom. As a general trend, the ionization enthalpy values decreases down the group due to increase in atomic size. Group 15 elements have higher ionization enthalpy than group 14. This is due to decrease in atomic size as we move from left to right along the period, as a result of which it becomes difficult to withdraw electron from it, and hence higher energy will be required for the removal of electron. However, the ionization energies of group 16 is lower than that of group 15. This is because of the extra stable half-filled p orbitals electronic configuration of group 15, due to which more energy is required to remove the electron from it. The last atomic property of group 15 elements is electronegativity. On moving down the group, electronegativity decreases with increasing atomic size, and therefore nitrogen is the most electronegative element of group 15 elements. So in the next part of the video, we shall discuss the physical and chemical properties of group 15 elements of the periodic table. Thank you.